Hi, so in this video I am going to talk about encryption and description of a file using RSA. So for that project it includes myself Ali Haider, Ahmad Shahzad and then Kanza Gohar. So to record that, first of all I have used these notes to demonstrate the working of RSA. After that I am going to do a real example on in the form of coding. So continue with RSA. So RSA is basically a asymmetric cryptographic algorithm. So asymmetric cryptographic means that it involves two keys. So first of all, we have public key and then private key. So the questions are, what are public key and private keys? So in public key, it is basically known to all users that are in our networks. After that, in private key, we actually keep this as a secret, which means that it is not a shareable. So if public key of a user is used for inscription, so then we are supposed to use the same. Let's suppose at that time we have a user A at for inscription. So when we are going to convert that into a private key, we are supposed to use the same key that we have used at the time of inscription for description. So RSA is basically a block cipher. So what does block cipher means? That it's plain text and cipher text, which includes integer between 0 and n minus 1. I would demonstrate them later in an example. So now let's talk about the RSA algorithm and how it works. So first of all, we select two large prime numbers. We basically select large to make it unbreakable or unhackable. So after that, we calculate n. So how we calculate n? We basically multiply those prime numbers p and q. Then we find phi of n. So we calculate phi of n by p minus 1 into q minus 1. P and q are the same values that we have taken in the step 1. Then we choose a value of e. So when we are choosing the value of e, there are two things that we have to keep in mind. First of all, it has to be greater than 1, and then it has to be lesser than the value of phi of n that we have calculated. It can be anyone. Let's suppose we have e as phi of n as 32, then our e can be 31, 30, but not 0 or minus 1. So we have to keep those things in mind. Then we would calculate d. How we calculate d? By calculating e inverse mod of phi n. E inverse same e its inverse and then phi of n. We take its mod. So then we calculate our public key and private key. So for public key we have e and n that is the value we calculated here. Then we have d and n. D is the value that we have calculated here, and then the n. So in, in inscription we have c is equal to m raised to power e mod of n. Then for description we have m is equal to c raised to power d mod of n. Now I am going to demonstrate it in an example. So for that we have to keep these steps in mind. So in first step we are supposed to select two large prime numbers. So I have selected little smaller numbers to make the calculation smaller, but it is going to be the same when we are using large numbers, because in computers it is not very difficult to perform the calculations, but when we are doing numerically, so it can be a little tough. That is why I have used small numbers, but for when we will be doing that on computer, I would be using larger numbers. So let's suppose we have two prime numbers as P is equal to 3 and then Q is equal to 11. So to calculate N, we have P into Q. So P was 3 and then Q was 11. 3 into 11, it is going to be 33. Then we then the third step was to calculate phi of n. So phi of n is equal to P minus 1 into Q minus 1. So P was 3 minus 1, Q was 11 minus 1. So 3 minus 1, 2, and then 11 minus 1, 10. 2 into 10, it is going to be 20. Then choosing a value for E, but keeping this in mind that it has to be greater than 1 and lesser than phi of n. So phi of n was 20. So let's suppose that we have selected 7. It can be 8, it can be 9. It's up to us, but it has to be lesser than 20. So now calculating D, that was basically our fifth step. So D was E inverse mod of phi n. So we take E's inverse and phi of n. Then after calculating, it is going to be 3. So we have the value of D as 3. And our E was 7 that we have already calculated. So now what are our public and private keys? Public key was E and private key was DON. So E was 7 and N was 33. Then private key D and N. D we had calculated it as 3 and then N was 33. That's 33. So now we are going to perform inscription. So inscription was C is equal to M raised to power E mod of N. So suppose we have taken this M as 31. So 31 raised to power 7 mod 3, it is going to be 4. C is 4. Now we are going to calculate M. So M is equal to C raised to power D mod of N. So C we had calculated is as 3 as sorry 4. 4 raised to power D was 3 mod of 33. So it is going to be 31. So that was basically an example that how we perform inscription and description using the RSA algorithm. So now let's continue with a practical example on the code. So as we have seen to perform inscription and description using RSA, there are basically three steps. So first of all, we perform the RSA algorithm and we calculate public key and private key. When we have both keys, then we can easily encrypt our data and we can also decrypt it. So that now we are going to perform the same scenario on our code. So here we have four files basically. So first basically in first one we would perform RSA algorithm on our plain text and then we would encrypt our text and then we would decrypt our text by using the same algorithm that we discussed here. So now let's continue with RSA. Here in RSA file we have basically what we did as we were supposed to select two prime numbers, so we did the same thing. We have basically used the range of 1000 to get both prime number, and as we have so we have generated both prime numbers. Now to generate the keys we we have used the same formula that we used here. P minus sorry, to calculate n we used p into q, and to calculate phi of n we used p minus 1 into q minus 1. Same thing we did here. So to perform n, to calculate n we used p into q, and then to perform, so we have written m as phi of n. So p minus 1 into q minus 1. So after the calculation, we are going to get uh, the same calculation as we did here to calculate our public and private key. We are going to get the same here. Now let's run this file. So after running this file, we would go back. So here, as we previously have seen, there were basically 4 files here. Now this is the fifth file. It is basically the key generator, which is going to give us our public key and private key. So let's see what we have got. So our public key and private key, and the values that we have calculated here, P, N, E, D, N. So these are the values, and it has successfully generated. So now when we have those values, so now what we are going to do, we are going to perform inscription. So how we are going to do the inscription? By using the same formula, m raised to power e mod of n. Inscription. So, so first of all, we would take the values of n and e that are basically uh, that are already generated here in our list. So what we are going to do, we are going to take both n and e values, and we are going to use both of them here in our inscription function using the same formula we used. So m raised to power e mod of n. Sorry. So m raised to power e mod of n. So we have used the same formula here by using both our values that we have already calculated n and e to perform the inscription. Now let's run our this code. So after running, what it is supposed to do, it is supposed to take our plain text and do the inscription that we have already that we have given it. So plain text, and now it has successfully encrypted it. So let's see how it has encrypted. It has encrypted it in this way. What was inscription data? It was basically, hello, this is for information security project. Now it is encrypted. We cannot basically recognize what here it has written. So now let's descript it back. So this was description file. So in this file we are going to do the same c raised to power d mod of n. C raised to power d mod of n. first of all, we would do the apply. So we would define the function, description function, power of c raised to power d, and then n, and we are going to use the same inscription text file so that we have inscripted. That was our inscripted file that was basically inscripted from our plain text. So now let's descript it, descript it back by using the same formula that we discussed. Okay, so let's run this. Yes, save it before running. Now let's go back and see whether it has successfully descripted it or not. It is so it is our descripted file that is generated. Now let's see. Yeah, hello, this is the information security project. This is the same file that was in our plain text. So this is our plain text file. Then it was inscripted in this form, and then now it is descripted back in the same file u- using our RSA algorithm. This was end of our project.